Hi everyone, I've made this video to help you with your homework. We've got Stage 2 Week 1 homework, which is the one I've set you, and there's a Stage 2 example work solutions, which is given there to help you understand how to do these questions here. Now, the two sheets are very similar. This one has got the same type of questions as you've got here. There's a Pythagoras question, there's a trigonometry question, there's a multiplying numbers question. They're the same type of questions, it's just that the numbers are different. The idea is that hopefully by looking at the examples here and how the teacher's done it, you'll be able to get the answers here and know how to work it out. And that's a key thing. Now, to help you even more, what I've done is I've actually going to make this video while I take you through these work solutions. So hopefully after watching the video, if you're stuck on a particular question over here, looking at the video how I do the same type of question on this sheet should help you. So let's have a look. So question 1 says 6.32 times 4.8 on the example. You've got something similar to do on your sheet. Now the key thing to do, I think, is first of all to take out the decimal point on both numbers. So instead of doing 6.32 and 4.8, you do 632 and 48. It's important that you don't use a calculator because you're going to need to know how to do this without a calculator for the exam. There's two different ways of doing it. I prefer this way if you know what you're doing here, but you can also do, I think it's called chunking, where you break it down. So 632 is 632 and 48 is 40 and 8 here. And then basically inside each box you do 4 times 6 is 24, add on the zeros, 1, 2, 3 zeros, 3 zeros here. In here you do 40 times 30, so you do 4 times 3, which is 12, and then add on the 2 zeros, which goes there. 2 times 40 is 80, 8 times 600 is 48 with 2 zeros, 8 times 30 goes in here, 8 times 3 is 24, add the 0, 240, and finally 8 times 2 is 16. And then all these numbers in this box, you arrange like that and you add up. You can see it doesn't really matter which way you do, you'll get the same answer. Now it's important to know where the decimal point goes in the final answer, because we've just worked out 632 times 48. What we want is 6.32 times 4.8. Now there are 1, 2, 3 digits after the decimal point in this question. So what we do is we take this answer, and to put the decimal point back we have 3 after the decimal point, because we've got 1, 2, 3 after the decimal point in the question. So 1, 2, 3, decimal point goes there, 30.336. If you think about it, it kind of makes sense, because this is almost 6 and this is almost 5, and 6 times 5 makes 30, and that's about what answer we've got here. So it makes sense, and that little check I just did is a good thing to do. Okay, let's look at question 2. We've got 6 lots of x plus 3, and then we're going to take away 2 lots of x plus 4. So what I would do first of all is multiply both brackets. So everything inside the bracket gets multiplied by the thing that's outside. 6 times x gives me 6x, and 6 times 3 gives me 18. And then minus 2 times x gives me minus 2x, and minus 2 times 4 gives me minus 8. So if I've done that correctly, I've already got myself a mark. Now I just need to do some tidying up. 6x take away 2x is 4x, 18 take away 8 is 10. And that's my second mark I would get for a question like this. Question 3 here, we are adding fractions together. When you add fractions, you need to make sure that the denominators are the same. So what I've done here, or what the teacher's done rather, is multiply top and bottom here by 2 to get 4 over 10, and top and bottom here by 5 to get 5 over 10. Why 10? Because it's a number that 5 and 2 both go into. It's really important that whatever you multiply the bottom number, the denominator, by, you multiply the numerator by that same thing. So 4 out of 10 is the same fraction, it's an equivalent fraction to 2 out of 5. 5 out of 10, as you can see quite clearly, is a fraction that's equivalent to a half. So these two fractions here are the same as these two fractions here. But what helps us is now we've got the denominators being the same. And so now we can add the numerators. 4 plus 5 is 9. 9 out of 10. And just a reminder, you never, ever, ever, ever add the denominators. So it's 9 out of 10. When you are dividing with a fraction, all you do is you take that dividing fraction and you flip it upside down and you multiply. So we're dividing by 2 over 3, so we multiply by 3 over 2. And now it's the same way as we normally do multiplying of fractions. 5 times 3 is 15, 6 times 2 is 12. 15 over 12. I can simplify that. I can divide top and bottom by 3. So divide that by 3 to get 5, and divide that by 3 to get 4. So I've got 5 over 4. I've got some marks already, but to get the final mark, I'll need to simplify that. 5 quarters, well, 4 quarters makes a whole, so if I've got 5 quarters, it's 1 whole one and a quarter left over. 1 and a quarter. Here, we're multiplying a fraction by a whole number. So we've got 5 lots of 3 quarters. So 5 lots of 3 quarters will make 15 quarters. 5 times 3 is 15. So we've got our 15 quarters. Now we need to turn that into what's called a mixed number. At the moment it's what's called an improper fraction, or a vulgar fraction, or a top-heavy fraction. Improper is the best word. 15 quarters. Well, every 4 quarters makes a whole one. So if we've got 15 quarters, we've got enough for 3 whole ones and 3 quarters left over. 1 whole one would be 4 quarters, 2 whole ones would be 8 quarters, 3 whole ones would be 12 quarters, 4 whole ones would be 16 quarters. So if we've got 15 quarters, we've got enough to make 3 whole ones, that's 12, and 3 left over, so 3 and 3 quarters. Question 4, we've got a sequence here. Now it's going up in threes. What we don't want to do is write n plus 3. What we're looking for is a way of working out what these numbers are when we know their position. So the first number is 5, the second number is 2, the third number is 11, the fourth number is 14. So can I find a way of working out what these are from the number above? So 1 makes 5, 2, second number is 8, third number is 11. I'm looking for a rule that makes 1 into 5, 2 into 8, 3 into 11. This is how I do it. The first thing I do is I spot that they're going up in threes. Okay? Now, whatever they're going up in threes, the rule to make this number here to this, it will involve multiplying by that number. So we're adding 3 like this. So the rule to make 1 into 5 and 2 into 8 and 3 into 11 will involve multiplying by 3. That's always the same number, just one's adding and one's multiplying. Okay, well 3 times 1 makes 3, but I need the answer to be 5. And 3 times 2 makes 6, and I need the answer to be 8. So the last thing is I need to add 2. So the rule is 3n, add 2. What's n? It's the number that goes above here, the position. So here n is 4 because it's the fourth number in the sequence. If I times that by 3, that makes 12, add 2, 14. You can see it works. Then the question asks me, what is the 20th term? Well, we know we can use this rule. So n is the number term. So here, the 20th term, n will be 20. So instead of 3n plus 20, it's 3 times 20 plus 2. So 3 times 2 is 60, plus 2 is 62. The 20th term would be 62. That's a much quicker way than going first number's that, second number's that, third number, fourth number, fifth number, sixth number, add 3 is 20, seventh number, add 3, 23. That's going to take far too long. This rule is better. Then it says, is 50 a term in the sequence? Okay, so we need to find out whether 50 is a term in the sequence. Well, what we could do is we could experiment with different numbers here to see if we can get 50. But we need to find a number here that 3n plus 2 makes 50, if it works. Well, if 3n's plus 2 is 50, 3n must be 48. And if 3n is 48, n must be 48 divided by 3, and that's 16. Now that's a whole number, and that means basically that the 16th number will be 50. So yes, 50 is in the sequence. If this was a decimal number, then we would know that that number here, 50, isn't in the sequence. Okay? If I tried 51, if someone asked me whether 51 was in the sequence, then that would be 49, and n would be 49 divided by 3, and that would get me 16.333333. And the fact that it's not a whole number tells me that the number isn't in the sequence. Next question here is about Pythagoras, and we remember that it only works for right angled triangles, and we label the sides A, B and C is the longest side, and we get a squared plus b squared equals c squared. So this is the side we need to work out. So it's 8 squared plus 7 squared, which is 64 plus 49 is 113, and then we square root it. So x squared is 113, so x itself must be the square root of 113, which is 10.6. Here we're working out the missing side here. So first of all, we label the sides. We've got the opposite. Why is it the opposite? Because it's on the other side of the triangle to the angle that was given to us. This is the hypotenuse. It's the longest side. And this is the adjacent because it's next to the angle. And we've got a right angle triangle here. So the sides involved in this question are the adjacent because it's 6, and the opposite because it's x. The hypotenuse doesn't figure in this question. No one's telling us what it is, and no one's asking us to work it out. So it's not hypotenuse. Now, using your sickness on holiday comes after tons of alcohol triangle in your books, you'll know that if it uses adjacent and opposite, it's a tan question. Okay, sickness on holiday comes after having tons of alcohol. You use your formula triangle, and you can work out that x is the adjacent times tan of the angle. Remember, the formula triangle is in your books. You cover up the thing you're trying to find out. What's left is your formula. Okay. Question 7a. 5x cubed times 2x to the power of 4. Well, you can see that the teacher here has made a mistake because it's not x to the power of 5. It's x to the power of 7. So 5 times 2, just multiply those numbers, is 10. X cubed times x to the power of 4 is x to the power of 7, not 5. Remember, you add the powers when you're multiplying. 3x to the power of 4 squared. Write it out. If you're squaring something, you're timesing it by itself. So it's 3x to the power of 4 times 3x to the power of 4. And now you just do it exactly the way you did this one here. 3 times 3, 9. X to the power of 4 times x to the power of 4. When you're multiplying, you add the powers, is x to the power of 8. When you're dividing, you subtract the powers. So when you're adding, beg your pardon, when you're multiplying, you add the powers. When you're dividing, you subtract. So be careful, don't do 9 divided by 3. You're subtracting the powers. So it's 9 take away 3, which is 6. Okay? For question 8a, you're trying to work out the value of these expressions when x is minus 5. So if I was you, I would take your time, because even though these are fairly easy, people make mistakes because they rush them. So write out x minus 2, and then wherever you see x, write minus 2. Wherever you see x, write minus 5, I beg your pardon, not minus 2. Whenever you see x, write minus 5. So it's minus 5 minus 2. You're taking away 5, now you're taking away another 2, it's minus 7. 3 lots of minus 5. Well, 3 times 5 is 15. So 3 times minus 5 is minus 15. Here, don't use a calculator. Just do it without a calculator, because a calculator normally gives you the wrong answer. So it's going to be minus 5 squared. Minus 5 squared means minus 5 times minus 5. Minus times a minus makes a plus. So it's 25. Add 1, 26. With a rectangle like this, you need to cut it into 2 individual rectangles. You can see the teachers cut it this way. They could have cut it this way to have a rectangle like that and a rectangle like that. Now you know what the area of a rectangle is, so the hardest part is just making sure that you've got the sides and you choose the right numbers to be the sides. So this is what some people do would be wrong. They would go 6 times 4 is that area, and 11 times 2 for this. That's wrong, Because can you see that 11 is this length? And that would mean that we'd counted this little bit twice. If we cut it this way, we need to know that bit, that's 4, that bit is 6, 6 times 4, 24. Write it in. Now, if this is 4, and this bit is 11, then this missing side must be 7, because 7 plus 4 makes 11. And now I can use that missing number to work out what the area is. 7 times 4 is 14. So that is 24, that is 14, added together, 38. Here, you're working out the volume of a cylinder. A cylinder is a prism. And to find the area of a prism, you find the area of the face, and then you times it by the length, or the height, if it's standing up. Now, the face of this cylinder is a circle, and the formula for the area of a circle is pi r squared. So pi r squared gives you the area of the circle, times h gives you the volume of the prism. The radius is 4, so pi times 4 squared times 10 gives you the answer. 4 squared is 16. Make sure you square the radius before you times it by pi. Don't do pi times radius and then square it. That's wrong. So 4 times, pi times 4 squared times 10. And that will give you the answer. Question 17, question 11. You're breaking the number down into its prime factors. Prime factors are prime numbers. Here we go. Here are the prime numbers that are factors of the number we're talking about. So, split 72 into 2 times 36, and 36 can be split into 2 times 18, and 18 can be split into 2 times 9, and 9 can be split into 3 times 3. And you can see that all of these numbers now are prime numbers. They've circled them. The teacher's circled them as they've gone along. So 72 is 2 times 36. 2 is a prime number, so he circled it, and then went on to 36 and split that into 2 times 18. 2 is a prime number, circle it, break down 18. 18 is 2 times 9. Circle the 2, break down the 9, and keep going until it's all prime numbers. So 72 is 2 times 2 times 2 times 3 times 3. Or you could write it as 2 cubed times 3 squared. Lastly, question 12 is, you've got to factorise it. So we've got 10 times x and 15 there. So we look to see what factors they share. Well, 10 and 15 are both in the 5 times table. So that factor of 5 that they both share goes outside the bracket. What's left goes inside. So we need 5 times 2 to make 10, and 5 times 2x to make 10x. 5 times what makes 15? 3 goes here. So 5 lots of 3 makes 15. There's your answer. Okay, I hope that video was some help to you. If it's not, message me, ask me, and see me in my office, and I can give you a hand. Cheers, folks. Bye.